Yes, trig functions most of the time comes a little bit surprised where all these things come from, but all goes down to one very simple fact. If you have two similar triangle, it means that, well, right triangle, I should write. If I have two similar right triangle, then I can go, oops, um, their angles inside are going to be the same. And by a very nice fact from the old geometry, you know that the ratio of corresponding edges for these guys are the same. So if I denote this one AOH and AOH, this notation is looking at this angle theta. Based on those very simple facts, we know that you take any ratio of two edges of these guys, they will give you the same thing. For example, if you take this one, if you take opposite over hypotenuse, or you take adjacent over hypotenuse, or you take opposite over adjacent, or, well, there are two other more, they're inverse of these guys as well. H over O, H over A over O. It's very interesting. Doesn't matter you pick the values from this triangle or this other triangle. The value A adjacent could be different, but when you find the ratios, no matter who did draw this triangle, the ratios are going to be the same. So it's mathematically, they say that these are invariant, meaning that in the everywhere in this world, someone does this, find this ratio, that will be the same. And that's why these guys are important, and we have the names for them. Opposite over hypotenuse is called sine, but since this depends on this angle theta, we call it sine theta, a cosine theta, and then tan theta. And then, while the inverse of the algebraic inverse of these guys, or reciprocal of these guys, have names also. You have to know secant theta, cosecant theta, secant theta, and co tan theta. These are 6 trig ratios which depend on theta, and we work with these guys. Well, simple versions of this, examples of this. For example, you can find all the angles here. For example, this guy, I want to find sine of theta. Here, the theta is this angle, the opposite is this, hypotenuse is this guy. Well, this I'm assuming is right angle. So sine is opposite over hypotenuse. So here 2 over 5 is given. Cosine theta is adjacent over hypotenuse. It's not given, but remember, if you have a right triangle, if you know 2 of these guys, you can find the third one as well. So here, this is Pythagorean theorem, basically. 5 squared equals, it's better to write it in blue, 5 squared equals to 2 squared. Oh, I see that I'm writing 2 equals to 0. This is O. 2 squared, oh, plus A squared. And from that, you can solve this and find that this is 25 minus 4 square root. This is root 21. So A is 21. So this will be 21 over 5. Tan theta, on the other hand, is going to be opposite over adjacent, which will be 2 over, was it root 21? Oh, I'm so happy today. That's why you'll see more mistakes from me. uh, well, reciprocal of these guys, this is cosecant theta is pi over 2. Secant theta is 5 over root 21. And cotan theta is root 21 over 2. I will leave the next example for you unless you have any question there. The only thing I will try to mention here is that you always choose opposite and adjacent um, with respect to the angle theta. So the edge which is on the opposite side of that angle, the edge at which this angle looks at is opposite. Here, sorry, I said opposite, I wrote A. This is opposite. Adjacent is this guy, the one, and then this is a hypotenuse. So you can find all trig ratios for this theta, for which we don't know the value for h the theta itself, but we can find the ratios. Any questions, any comments here? Well, some specific values are important for us. Out of these ones, there are 4 or 5 important, and you have to know these values. So trig ratios for these 5, we call them special angles. There are different ways to memorize it. Most of the time, you will see me only covering sine, cosine, tan. You know that the reciprocal of these guys are secant, cosecant, and cotan. So if you know these guys, you know everything else. So that's, but to memorize these trig ratios of these special angles, there are more than one way to memorize it. So this table, you have to have it in mind. For calculus 1000, it cosine of pi over 3 is like 1 plus 1 is equal to 2. You have to have it there ready. How to memorize it? Why some people like to use these special triangles, some people call it, different versions of that. Some people like to learn how to memorize this table. And there's also another way. Do you guys, does anyone know how to use the fingers to find these values? The hand. Have you guys heard of that?
Is it like where you put your hand out and then like you put the finger down and then the ones on the top and the bottom show you like what it is?
Exactly, yes, yes. So here we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. If you're trying to find anything, you like something for pi over 6. This is pi over 6. I close it. Then this part is going to give you cosine. These 3 are going to give you the sine. The way this works is that the numbers below that, the number of fingers below that is 1. Find the square root of that. So square root of 1 divided by 2. That is cosine of pi over 6. And you can check it in this table. It's 1 over 2. This guy. The number of fingers up here, root of that divided by 2 is sine. What I'm doing here? Am I making a mistake here? Definitely I'm making a mistake. This guy is cosine. Oops. Yes. Now. Oh, this guy is sine. Oh, I have to practice working with my fingers. Oh, this is good. And this way you can, well, there are other ways. The goal is that you have to know how to work with these 5 values. Everything else, 90%, will boil down to these cases. Any questions, any comments here? Yes, I should practice a little bit. Of pi over 6. This is the sine. Root of that divided by 2. This is cosine. Yes. Yeah. So this, the farthest you can go with these triangles is the theta must be between pi over 2 and 0 is well, trig ratios. For these thetas are defined by, say, triangles. Yes, this is right triangles. What happens if theta is more than these guys? So what about other values of theta? For this, you have to generalize this idea, and while something comes in is called what is it called? Trig circle. So what happens is that you pick a unit circle with radius 1, and you know that for any theta, well, when you measure it in radian, you want to go this direction. So counter clockwise direction gives you positive angles. Clockwise gives you the negative one. Now, when you have an angle, well, you go around several times, I don't know, maybe one time or halfway, and you find an angle. Well, doesn't matter what is that angle. Well, but this means that you start from there, you go up to there. Then the intersection point of that ray and this unit circle, well, this is a point, and it has x and y coordinate. Note that this x and y now can be different values. And then in that case, you start defining these ratios. Now, for more general values of theta, for sine, this is always going to be y. For cosine, it's x. And for tan is y over x. Reciprocal works the same way, while secant theta is 1 over cosine theta, cosecant theta is 1 over sine theta, and cotan theta is 1 over tan theta. There is one thing important here that you have to know. This number y over x will work only if you take circle of unit radius or unit circle. If you do in general, you have to do it y over radius or x over radius, or well, this one will work as is. This one doesn't matter. But if you pick r to be 1, then you don't really need to bring that r into your ratios. Let me show you an example how this works, and right away you will notice that, oh, this guy is nice. This will work. This will work for more general angles. This idea of working with the trig circle. Before I start doing examples, is there any questions, any comments for me? Okay, so always start with
Quick question.
sure, sure.
Uh, this is slightly deviating away. But it's a question that I got for physics and including trig, and it's driving me crazy because I can't tell if I'm just being dumb or if I'm missing something.
Well, when you're working with the trig functions, you're never dumb. This is always confusing. Don't worry about that. Okay, that's one thing. But is it a question? Can we keep it for the end of the session? Maybe when we are uh, when I'm done with the questions, and then at the end you ask that. Is that okay? Or do you want quickly answer? Let
It
me see if I can answer right away.
it's very quick.
Sure, sure.
It's 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 a right angle triangle, and
Mhm.
I have the hypotenuse, but I have to divide the value of the hypotenuse into its x and y unit components.
Sorry. Oh, you have right triangle, and then you have hypotenuse there. The value for the hypotenuse.
Yeah,
Okay. And then what was the question?
I have to divide it into its x and y unit components.
Oh, you're writing the, are you working with the vectors?
Yeah,
Oh, I see. Oh, well, if you have the length of this guy, and well, let me just write it h, and you have this angle here. Oops. If you have the angle here, then cosine theta times that hypotenuse is x value. Cosine sine theta times the hypotenuse is going to be y value.
yes, but I don't have the angle. Would I have to use
Oh, do you have the vector as like AB?
yes.
Well, then that's x, that's y. Already they're given. The coordinates are already given. Okay, let us just keep it to the end. Is that okay?
Yeah.
And if you still have question, we can go over that at the end. Okay, so I want to work with this guy here, and then I have a circle, unit circle. I try to have it centered somewhere. Oh, nice. Now, I'm trying to find 10 of 8 pi over 3. So you can choose different ways of locating this angle on this trig circle. There are different ways. For example, one can say, oh, this is, you see, this is 6 pi plus 2 pi, and then divided by 3. And this is tan of 2 pi plus 2 pi over 3. I like this way of thinking about the angle, because if you have extra summand of 2 pi's and you can take it away, it means that you're just taking away going around the circle. Going around circle one time is 2 pi. So when you're back to the 0, it will give you the same values. And then from there, you see that this is basically 2 times pi over 3. I assume that you know what is pi over 3. Pi over 3 is 60 degree. It means that you divide this right the straight line, straight angle to 3 equal pieces and pick one. Oops, all gone. Okay, and pick one of them. Yes, this is pi over 3. Now I want 2 of them. So this is 1, this is 2. So I go 1 there, 2 there, and 3. That's locating the angle there. Well, one could have done this from the beginning, saying that, oh, 8 pi 8 pi over 3 is nothing but I pick 8 of these pi over 3s. So 1, 2, 3, 4, 5, 6, 7, 8. This is the angle there. We found the angle. Now, I want to find this point here. The important fact that I will need to use is this, that that the remaining, the completing part of this guy, since there I have already taken 2 of third of pi, the remaining will be pi over 3. I know that the radius is 1. The only thing now I have to make sure to understand is that what is the x and y of this? And this is pi over 3. Remember, oh, it's not very nice pi over 3, but I'll try to. One of those angles that you have, this is pi over 3. I will use the triangle, one of those special triangles. If hypotenuse is 1, this guy is going to be 1 over 2. This guy is going to root 3 over 2. So it means that I have these values there. I can do this. The length of these guys now I know. This is 1 over 2. This is root 3 over 2. This I only know the length, but I have to be careful because the x coordinate here, which is given by this guy, is on the left-hand side of the y-axis. So that means that the coordinate of this guy is going to be negative root 3 over 2. And the, oh, I did make a mistake actually here. I did put the wrong numbers. Okay, this is half. This is root 3 over 2. X is then, x is negative half, and y is root 3 over 2. Yeah, I hope so. Oh, I have questions. Below, yes, please.
All right. So just to verify, when you had 8 pi over 3, and then you kind of, I guess, like simplified it, what was the reasoning for that?
Yes, I'm not simplifying. Okay, so it's a good idea to see what I'm doing there. I'm trying to locate this angle. Okay, use any method that tells you how to do locate this angle. The way I liked it and I did it was that I separate the pieces of 2 pi. Each 2 pi means going around the circle once. So as if I'm starting from the beginning, I can drop that 2 pi and just start with the rest. Now, the rest is 2 pi over 3. What is the angle 2 pi over 3? This is the straight line. You divide it to 3 pieces, pick 2 of them. That was my argument there.
Oh, so once you looked at 2 pi over 3, then you were able to, I guess, like
yeah, the remaining part is 2 pi over 3, and then I say that, okay, this whole thing is pi. Oops. This whole thing is pi. I divide it equal 3 pieces. I pick 2 of that. The remaining part, which is here pi over 3, I located the angle. The angle starts from the very first place, goes around 2 pi, and then comes back and picks only 2 of those guys.
Got it. And also, when you were looking at pi over 3, that's once again like the chart that we would have to memorize, right?
Yeah, well, either you remember that chart, or you have to be because in that chart you still need to be careful about the signs. Yes, is it positive, negative, is not in that chart. That's why I usually say that you try to put one of those special triangles, fit it in your angle so that one of the edges of this triangle sits on the x-axis.
Okay, and we were just trying to find like the
point.
Okay, got it. Thank you.
Alexandra?
I was just wondering why you did, like, you drew the diagram in the second quadrant instead of the third quadrant where like tan 8 pi over 3 would actually be, because then it doesn't take account the cast rule.
Wait a minute. So let's do it again. Let's do it. You claiming that it will be on the third one?
Like,
You see, okay,
in the
8,
bottom left.
8 pi over 3. Is it okay? I go this way. I will do it a little bit different now. I say that this is pi. I divide it to 3 pieces. This is pi over 3. Each piece is pi over 3. Yes. And I do the same thing down there. So now I go around 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8. I'm back on the second quadrant.
Okay, I was just thinking of it like a different way, because like when I was in high school, they taught us to like do it like,
How about try to learn this thing?
okay.
Yeah, this is fresh. I'm teaching you this. This is magical. You learn this one. How about that? Well, usually the point is that no matter what method you use, you have to make sure, first of all, you remember it complete. And then if the method is correct, it should give you the same thing. If the method you have in mind doesn't give you this one, at least for 8 pi over 3, now that I have done 3 times, and I'm sure that's correct, it means that you either you need to go refresh what you learned there, or there is something wrong with that method. I'm not claiming it's wrong, but either one happens, and that's why you have to be careful in that case. Willow, do you still have question, or you forgot to lower your hand?
Oh, sorry, I forgot to lower my hand.
Okay. So for the other two, I will set it again for you to complete. I will just only do one of the, oh, by the way, I'm not done. I found this guy. Now I have X, I have Y. The tan of this is going to be Y over X, which is √3 over 2 divided by -½ and that is √3. When you're doing these things, you have to be careful about the sign of the ratio that you're getting. And I'm not sure if you have watched the videos. I put that funny things there, that if your angle is on the first quadrant, second quadrant, third, and fourth, you know what are the signs of sine, cosine, and tan. It comes from one thing. All the students take calculus. So this all here means sine, cosine, and tan. All of them are going to be positive. Student starts with S, so only sine is positive. Cosine and tan, these are negative. Take starts with T, so tan is positive, and sine and cosine are negative. And this goes for the last one, which is only cosine. Calculus starts with C, cosine is positive. The other two are negative. And you can now check that. Oh, okay, we were in the second quadrant. Tan was supposed to be negative. It is good. It is negative. Any questions? Any comments there? Okay. One of the things which is very important, and I would suggest that you try to do, well, actually, you have some questions in the quiz one, similar questions. So one trig ratio of the theta is given. I don't know what is the angle, but I can find all the other ratios if I know which quadrant the angle is in. So here, sine theta theta is an angle, sine theta is -2 over √7. And I know that it is in the third quadrant. I don't know what is theta. Theta is just a strange number there. It's not, definitely is not one of those special angles, but since I know what is the sine, I can do something with this theta. It's in the third quadrant, and also somewhere here. It means that theta is starting from there and goes there. Sine, remember, sine, if this point has two coordinate x and y, and we are working with unit circle, this means that this guy is equal to y. So this means my point is x and -2√7. I have this right triangle here. I'm just fitting this guy there. The hypotenuse is 1. The x, the y one, sorry, the y coordinate is given is 2 over √7. Here I'm just writing the length. What would be this guy here? Well, I can use a Pythagorean theorem. So x squared plus 2 over √7 squared is equal to 1 squared. That means that x is either plus or minus 1 minus 2 squared is 4. √7 squared is 7. And that will give me 7, 3 over 7. And you go from there, yes? But this, if I use Pythagorean theorem, it will give you the length, which is positive. But since x is negative here, I can find from this part that this must be negative. So x is -3 over 7. So that means, oops. That means that I have found the cosine theta, which is negative, which is x. I found x is -√3 over 7. Okay. Well, you have to be able always to apply this thing. So first, go to the quadrant and see the given information. Which coordinate that does that give me? And then use Pythagorean theorem, find the other coordinate. Use where you are on this quadrant, and then fix the sign of that, and then go from there. Well, when you have x, y coordinate, you can find all the ratios. Adam.
Hello, Professor. Couldn't you think of it in a way saying you could think of y as -2 and then the hypotenuse as √7 as r?
Yes, yes, that's also another way. I like to keep my trig circle to be unit circle, but you're okay with going with other triangles because all of them will give you the same thing. This one, this, y you're taking as the -2. Well, when it's in the case of, yes, and then you can find here, which will be √7, I believe, √3. Yeah. And well, you see, yes, so you have to bring in that sign kind of thing. But if you're using that kind of fact, then cosine is not going to be x. It's going to be x over r, which is, yes, do you see that? In that case, it's a little bit different story, yes?
Yeah.
But that will give you the right answer if you do everything correctly.
Okay, thank you.
I will leave the other one for you. How about that? This one for you, just an example to do it. And I'd rather to move to do 1-2 questions from the trig identities rather than sketching the graphs. In the case of sketching graphs, you have to know the basic graph, sine, cosine, tan, and then how does the transformation. We have done enough examples in our previous sessions about the transformations. So I will leave sketching the graph for now aside, and then go to the trig functions, the trig identities. Any questions, any comments? Adam, do you have still question, or you forgot to lower your head? Okay, so I will go for the trigonometric identities. I will quickly tell you about few things. Well, one important trig identity is the basically Pythagorean theorem. It says that, well, if you're working with one here, cosine here, sine here, then sine cosine squared plus sine squared is equal to 1 squared. That's the first thing that you have to know. The second one, these are very important and you have to know them. This is sum of angles. If you have sine alpha plus beta, this will be sine of alpha cosine of beta plus cosine of alpha sine of beta. And then you have the third one, which is cosine of alpha plus beta. This will be cosine alpha cosine beta minus sine alpha sine beta. You have to know these three. These are the main ones. Almost everything else, at least in this course, comes from one of these guys. For example, when alpha is equal to beta, we have double angle formula. Sine of 2 alpha is equal to 2 sine alpha cosine alpha. And if alpha is equal to beta, this gives us double angle for cosine. So this is cosine squared alpha minus sine squared alpha. It's interesting. If you add cosine squared to sine squared, you get 1. If you subtract them, you get cosine of 12. But then you can combine this and that. And for example, instead of writing cosine square, you can write 1 minus sine square. So that will give you another formula there. This is for double angle. Or if you do one more cosine 2 alpha, you can do write sine as 1 minus cosine square, then this will give you this guy. And then, well, you can turn these guys around and find the half angle formula, which is equal basically sine of alpha over, well, I'll write different numbers because I want to show you this one. So this will be 1 minus cosine theta over 2 square of that. Cosine squared theta over 2 is 1 minus cosine theta. 1 plus. Yes. And these are some other tricks that you can use to find ratio of some or trig values of some angles. Willow, yes, please.
Sorry, really quickly. What is the difference between, I guess those two formulas that you wrote, the cosine 2 alpha, and then there's like 1 minus 2 and so on and so forth, and then the
Yeah.
other one.
Yeah, you see, in the right-hand side, the double angle thing, if you know the sine of an angle, you can find cosine of double of that angle. Like if you know, I don't know, what is sine of pi over 10, you can use it and put it in the right-hand side and get cosine of pi over 5, double of pi over 10. But for the other formula, this is the other way around. If you know cosine theta, you can find sine of half of that.
Okay.
Well, this is not very precise because the square of that is given, and you have to be careful about is it positive or negative? But that's basically why it's called, this guy is called half angle. This guy is called double angle. But those are the same thing, baby. Those are not different.
So that formula, the one that you highlighted is, it's the same thing as the one on the bottom.
Well, actually, I just wrote how to get them. So this is just rearranging this guy to get that one.
Got it.
The
Okay.
other one is just rearranged to get it the other.
Oh, okay, got it.
Yeah.
Thank you.
Kiara, yes, please.
Do we have to understand how you relate all the identities, or do we just memorize them?
Oh, I see. This is easy. This is Pythagorean theorem. Yes.
Mhm.
This guy and this guy, proof of these ones are not easy, and we are not expecting you to know.
Okay.
But we expect you to know double angle formula, which are just straightforward of going from one of these to the other ones. These ones, this one, this one, this one. So when you list them, it seems like, oh, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 identities. But no, in practice, we have 1 identity, 2 identity, 3 identities. The rest can be obtained from those 3.
So we should know how to obtain them.
Myself, I cannot memorize those ones. I just know these ones, and anytime I want in my mind, I just do the math and get the other ones.
Okay.
But if you're okay, we are not going to ask you to prove it, but know that algebraically you have to be able to handle such level of proof, like manipulating the identities.
Okay, thank you.
Willow, do you still have question or just forgot to lower your hand? Okay, great. Let me just do one example. I know that we are almost done, but let me just do one example of this and then we go. Okay. This guy here, cosine of pi over 8. Oh, cosine of pi over 8. This is not a special angle. And it's not one of those questions that one trig ratio is given and we are asking to find the other one. This, you have to see that this is nothing but half of cosine, I would say half of pi over 4. Why pi over 4 is important to me? Because pi over 4 is one of those special ones. And if I use the half angle formula, I know that cosine squared of theta over 2 is equal to 1 plus cosine of theta divided by 2. So, well, that means that if I have pi over 4 there, pi over 4, the right-hand side tells me that, oh, look, cosine of pi over 4. This is one of the special angles. And you have to note like that's root 2 over 2 divided by 2. So I found that, well, I can simplify this a little bit. This is 4, 2 plus root 2. Okay. Now you know that cosine squared of pi over 4 divided by 2, which by the way is cosine squared of pi over 8. At the moment, I don't care about that side, is 2 plus root 2 over 4. Then square root of that, either plus of that or minus of that will be cosine of pi over 8. Can anyone tell me, is it going to be plus or minus in this case? Can anyone tell me, is it going to be plus or minus? Taylor, yes, please.
It's going to be plus, right?
Why is that?
Because it's in the first quadrant, and that's all.
Thank you. Yes. So Taylor is using the fact that, okay, I know that pi over 4 is somewhere here. So pi over 8 is going to be here. So this is in the first quadrant. And first quadrant means that, or cosine must be positive. Everything is positive. So that means that this will go away and we will have, oh, this is the number we were looking for. Curious, please.
Where did you get the square root sign from? Where's that coming from?
Oh, you see, wherever you're solving, oops, wherever you're solving something, you're looking for a number whose squared is given by a number, 10, whatever the number. Well, I'm looking for a variable whose square is 10. You have to do square root of that, yes?
Mm-hmm.
I'm solving an equation. What is the square root of x squared?
X. X. The square root of x squared?
Its square root of x squared is not x. It's absolute value.
Oh, sorry. Okay.
Yeah, there is a subtle. I know that most of the time it's not clear to see. So I know that absolute value of that guy is going to be root 10. That means that that guy itself is going to be either root 10 or negative root 10. That's where this plus or minus comes in. I'm not saying it's going to be both of them. I'm saying either is that or that. Now, in this case, we have other facts, which Taylor told us, and this says that, okay, this is the first quadrant, so cosine must be positive. I drop the negative 1 and then get
Okay.
Alexander?
When we draw our like graphs, you know how normally a graph would be like 0 degrees, 90 degrees, 180, 270, and then 360 back around? Could we use radians there instead to help us place our arm so like we know where to place it properly?
Yes, okay. This is a question of basically you're asking which measure I should use. Am I understanding that right?
Yeah, like I just thought like on when we draw a graph, like where to draw our terminal arms, we're allowed to use radians just so we can place like pi over 8 so we know where it goes easier in our head. Like, is that allowed?
Yes. I would suggest in this course you try to work with radian only.
Okay.
It's good, but you see, compare radian with the degree. Degree is just a convention. We just decided to divide the whole circle to equal 360 pieces. That's the convention. Why 360? Why someone else come in saying that, oh, let's do it 400 pieces? Well, there are definitely historical reasons for that, but it doesn't seem that there is a good mathematical reason behind that. compare it to radian, which is completely working with which portion, how big portion of unit circle you're picking. In calculus, we are going to work always with radians. Even when we are drawing the graphs, this is important, especially when we are working with the derivatives and so on. We are not using 180, 360. This is the x-axis, in this case is radian. This is pi. This is about 3.1, 4, and so on. So if someone wants to compare this with 4 would be somewhere here. But if I put 180 there, that's not my angle. That's not my right triangle, like right scale. Any other questions? Any other comments? I know I'm over time, but before I go, let me ask you this one. Can anyone tell me how should I deal with this other example? I want you to see that. Seven pi over 12 is not a right angle. And no matter how many times you go around, it's not going to help you to get into any of the special angles. I know all you are tired, but let me just write this one. Seven pi over 6 itself is not a right angle, a special angle, but I can turn it into one of those special angles. And I can find cosine of 7 pi over 6. And then use the half angle formula and get the sine of those ones. Before I go, I'll just write one hint for this guy, and I'll ask you to do these ones as well. Hint. Tan, remember, is sine over cosine. And you have addition formula for sine and cosine. Use those ones and you will get the result for that. Okay, that's all me. Let me just pause the recording.